application problems. This is working out number 16 in your homework, and then I'm going to follow it up with 17. And I'm going to share the screen so we can take a look at the problem, the wording of it. And let's see here. We have a rational function 100 over 101 minus x, where x ranges between 5 and 100. And it models the disparity between the percentage of the population and the percentage of the postings on social networks. When the population is ranked by number of postings, so in this formula, f of x outputs the percentage of the posting done by the least active or the bottom x% of the population. Now in this problem, it says evaluate f of 74. I did this problem earlier and I used 98. So I'm just going to use 98 so that I don't have to rework the problem with a different number. So let's take a look. We are going to evaluate our function at x equal 98. And f of 98, I'm going to plug 98 in for x. That'll give me 100 divided by 101 minus 98, which is 100 divided by 3, which is 33.3%. Okay, now it's asking us to then evaluate f of 100. So we have 100 over 101 minus 100, which is 100 over 1 equals 100%. And that makes sense, right? If you're looking at 100% of the population, then the social postings are going to come from 100%. If you're looking at, let's read that problem again. So let me share my screen. All right, so it says here that in this formula, f of x outputs the percentage of the postings done by the least active or bottom 100% of the population. So this is the percent of postings by the bottom 100%, which is just the entire population. So it makes sense that the entire population is going to post 100% of the postings, whereas the bottom 98% is only going to post 33.6 or 33.3%. So that means, let's take a look at that again. So that means that if we take the difference, okay, we have f of 100 minus f of 98, this is just going to be 100% minus 33.3%. So this is going to give you the postings, the percent of postings by the top 2% of the population. So you have 67.7% of the postings are done by the top 2%. So this is the postings by the top 100, which is all of them, or I'm sorry, the bottom 100. And then this is the postings by the bottom 98. So if you take the difference, you're going to get the top 2%, and that's 67.7%. And that's the interpretation. Okay. Now let's take a look at the next problem, number 17. The function that we're working with in number 17 is n of x equals x squared over 3,000 minus 60x. And we're given that n of x equals 8. So let's take a look at that problem real quick. So here we have our function, and this problem says n of x equals 5. I did it with 8. So it just is at a parking lot. The attendant can wait on 50 people per hour if the people arrive randomly at an average rate of X cars per hour. The average number of cars n waiting to exit the lot is given by this equation where X is less than 50. And there are some parts that we have to finish. Okay, so we're supposed to approximate X when n of X equals 8. I did it for 8. In this problem, they're asking for 5, but let's just do it for 8. So we want to know. So we're going to replace n of x here with 8. And so we have now a quadratic or a rational equation, which can be converted into a quadratic as long as x is not equal to 5. Okay, so I'm going to multiply both sides. And I'll do it in plain so you can see what I'm doing here. I'm going to multiply both sides by this denominator to get rid of the denominator. So on this side, it's going to be 3,000 minus 60x. And then also on this side, 3,000 minus 60x. So this is going to cancel. And by the way, you can solve this using your graphing calculator too. I just find it easier to do it this way. Okay, so now I've gotten rid of my denominator. Now I'm going to distribute this 8 through, and that gives me 24,000, because 8 times 3,000 is 24,000. And then minus 60 times 8 is 480, so minus 480x, and that's equal to x squared. And I like the leading coefficient on x squared to stay positive. So I'm going to move everything over this way. I'm going to subtract 24,000, and then I'm going to add 480x to both sides of the equation. And then I'm going to get 0 on this side, and I get x squared plus 480x minus 24,000 equals 0. And this is the quadratic equation in the proper format. A equals 1, B equals 480, C equals negative 24,000. So by the quadratic formula, I get minus B, x equals minus B, that's 480, plus or minus the square root of B squared, that's 480 squared minus 4 times 1, that's A, times C, which is negative 24,000. And it's all over 2 times 1. All right, so that's, when you do this on your calculator, I went with the positive sign. I didn't calculate the negative because we know that X has to be positive, right? X, again, is the number of cars. So let's see. People arriving randomly at an average rate of X cars per hour. So you can't have a negative X. So that's why I don't calculate this negative. I use the plus. Because I've got already a negative here, and I better add a bunch of more than 480 to get a positive number. And when I put that into my calculator, I got 45.657, and they tell us to round it up. So I got 46. Okay, but we round it up because of the 6 there. All right, so what does that mean? Okay, what's the interpretation? If you have cars arriving on average at 46 per hour, the line will be on average 8 cars long. So that's the interpretation. We're given the 8 cars and we found that it's, if they're coming in on average at 46 per hour.